In this example, we're going to take a look at what happens when you have a standing wave on a string. What's a little bit different about this problem is that I'm giving you the ninth harmonic frequency as opposed to just the fundamental frequency. So you have to work backwards to figure out exactly how long one single wavelength is going to be. The easiest way to do that is to just draw out a quick little picture. Since I know that the string is 7.3 meters long, just going to draw that out. And I also know, and this requires really an understanding of standing waves, that the first harmonic is going to have just a single loop. That means that the ninth harmonic is going to have 9 loops. So if I have 9 loops, that means if I just kind of draw this out, I'll try to do this as best I can. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it's a little short. So let's just say 7.3 meters is here. So here are my loops. What I can do then from this picture is I can just figure out exactly how long one loop is, because I know that the 9 loops take up 7.3 meters. So all I have to do is take 7.3 divided by 9, and that gives me the length of each loop. So I know each one's going to be 0.811 meter. Now that helps me because I know that 2 loops is equal to 1 full wavelength. So I know that 2 loops is going to be my 1 wavelength. That means 2 of this length, 0.811 meters, is going to be my wavelength. So the wavelength in this case is just going to be 1.622 meters. So when I have this ninth harmonic with this frequency, this is going to be my wavelength. The next thing I can do is just use my wave velocity equation. So velocity equals frequency times wavelength. So I don't know the velocity, but I know the frequency at the ninth harmonic is 12.4 hertz. Since the frequency is 12.4 hertz and the wavelength is 1.622 meters, I can just plug both of those in, just multiply those together, and I can get my velocity, which is 20.113 meters per second. I just want to point out this is not the only way to solve the problem. This is one way to look at it, and that's just drawing out the picture and then figuring out the wavelength when you have your ninth harmonic. The other way to actually do this is if you understand that the frequency is a multiple of your fundamental, you can actually take that frequency of the ninth harmonic, you can divide it and get your fundamental frequency. And once you have your fundamental frequency, you can say, okay, 7.3 meters is going to be the length of one loop, and you can use that. No matter if you use that way or the way I showed you here, you should still end up with the same wave velocity. It's not going to change your final answer. It's just there's not just one way to solve this problem. And I want you to understand that there are several approaches that I would accept.